This question starts us off with a couple of right triangles, but before we get into the real details of this prompt, there's a couple of things we got to discuss. First off, since this is geometry and it's data sufficiency, we know that the picture is not trustworthy. It's not necessarily to scale, so we can't use it to do any estimations. I know that there's right triangles, so I can use the Pythagorean theorem, and I know that the hypotenuse will be the longest line in each triangle, but I don't know the relative sizes of anything. As a result, that leaves me with a ton of variables to deal with. In addition, this is a multi-shape geometry question. That means it's a lot harder than average, it takes a lot longer than average to solve, and it's not worth anything unless you're already awesome at everything else in the quant section. So if you're looking for a question to strategically eliminate, to dump a question quickly and move on so you can get to everything else, this would be a perfect opportunity to do so. I'm going to show you how to do that, and I'm actually going to show you how to answer it once we get the rest of the information down. But this question is really worth nothing, and you need to be comfortable with the idea that you could jump past it on test day, just take a guess and move on, and be rewarded for being an adult. Let's talk about the question. It asks, is triangle ABC, the area of it, equal to the area of triangle ABD? So I'm going to get that down. Is area of ABC equal to the area of ABD? So on top of everything else, we're looking at a yes-no question, which just adds to the difficulty and level of detail we would need to have to beat this thing. Since we're dealing with an area of a triangle versus the area of another triangle, I'm going to write down the area formula, 1/2 base times height. Note that there are two different triangles, so there are two different bases and two different heights. Even though related via math, they are two different lengths, so I have to treat them as such. So now let's talk about the facts. Fact 1 is messy, it's detailed, it's ugly. So let's leapfrog it and go straight to fact 2. It says that triangle ABC is isosceles. But notice how it doesn't tell you anything about the length of the base or the height. It doesn't tell you anything about triangle ABD. This is not enough information to tell if the area of one thing is equal to the area of another. So fact 2 is an immediate insufficient. And with that information, you could actually knock out two answers, knock out D and knock out B. You could take a guess. You'd have a 1 in 3 shot. You could leapfrog this question completely, save a bunch of time, and be rewarded for it. That actually is the smartest thing you could do right now. But if you are going to stick this one out and attempt to answer it, here is the easiest way to do so. Fact 1 compares two side lengths and says AC squared is equal to twice AD squared. Now, there are a couple of ways to approach this, but I don't want to do a lot of crazy geometry and algebra, and I'm sure that's what the official guide is going to tell you to do. I'm going to show you how to beat this using test it, because we have to talk about what would happen if we had actual numbers. Now, since we're dealing with right triangles, I'm going to start off with some real easy examples. I'm going to make triangle ABC a 3, 4, 5 triangle, and then calculate everything else. So let's make the base a 3, the height a 4, and that would make the diagonal a 5. But that also makes the base of the other triangle a 5. Now we can do some basic algebra. Since AC is 4, that means this equals 16. That's equal to twice AD squared. And now you're just a couple of math moves away. You would figure out that AD is equal to the square root of 8. So I'm going to plug that into the picture. And now let's talk about areas. The area of the first triangle is 1/2 times 3 times 4. That's 6. The area of the second triangle is 1/2 times 5 times root 8. Now, you could do a little bit of math here, but I'm pretty sure you'd realize that 2.5 times the square root of 8 is not 6. It's close to 6, but it's not 6. So you can look at this and say, these two areas are not equal. In this first example, I would get a no answer. But notice how fact 2 mentioned isosceles triangles. Maybe that's something we should test. So now I'm going to make a minor shift here. I'm going to turn our starting triangle into a 4, 4, 4 root 2. So the base will become a 4, the height will stay the same, and the diagonal will come as 4 root 2. This root 8 stays the same because the 4 was the length of AC. And now we have these areas, 1/2 times 4 times 4, that's equal to 8, versus 1/2 times 4 root 2 times root 8. Now here you got to do a little bit of work with the root 2. I'm going to rewrite this as 2 root 2. So multiplying all of these little pieces together, I've got 1/2 times 8 times 2. The 2 and the 1/2 cancel, and now we have 8 versus 8. In this example, we would have two areas that are the same. So 1 no, 1 yes makes fact 1 insufficient. And this, honestly, is the easiest way to prove that it's insufficient. What you would find in the official guide as an explanation is going to be horrible, I guarantee it. Now, the safety at the end, the shortcut at the end is, because we know that the triangle is isosceles, triangle ABC, we get put into the scenario in which the areas are always equal. That is a very rare math rule, and it's not one you're expected to know on test day, but you'd have enough of a pattern here to say, well, isosceles triangles end up giving us a yes answer, and since I know that ABC is isosceles, I'm going to call this sufficient together, and that means C is the answer. Now you can look at all this work and realize how nasty this thing is. It's layered with pitfalls, potential mistakes, or potential things you might miss. That's how hard it really is, and that's why it's worth nothing. Business schools do not care at all if you get this question right, so don't go wasting a lot of time on it. If you have strong pacing skills, go ahead, spend a little bit of time on it, but the truth is, the best test takers, the killers, they're the ones who are dumping this question the moment they see it. They take a quick test, they move on, they save a bunch of time, and they're rewarded by having enough time to get to everything else, including the questions at the end that count. You want to be part of that group, you got to make the smart choice. Dump this question when it shows.